Seniors. Today we're going to talk about solving systems of equations. So let's go ahead and jump in. On your notes page, go ahead and draw your line. Go ahead and write solve systems of equations. Don't worry about all this yet. Just be with me. I'll tell you what to write. So systems of equations are just pairs of equations of straight lines. So if I just had y equals 3x plus 2 and y equals 3x plus 4, since there's two of these equations, they're technically called a system of equations, but they're both straight lines. So today we're going to be working on graphing two lines on the same graph and figuring out how many solutions these have. So this will all make sense, just hang on with me. So there are three possibilities, and these I want you to write down. Our systems of equations could have one solution, no solution, or infinite solutions. If it has one solution, it means that the two lines that you graphed cross once on the graph. If it has no solution, it means the lines are parallel and do not cross. So if I had a graph and I had a line going this way and a line going this way, that systems of equations would have no solution. We'll do a better example of that in a couple of minutes. And lastly, there are going to be some lines that you graph that are going to end up being the same line. And if it's the same line, it has infinite solutions. So make sure that you have the one solution, no solution, and infinite solutions down in your notes page. So when I say solution, I mean a coordinate that will make an equation true. So I have the example, is 1, 6 a solution to y equals 2x plus 4? Well, if I plug in 1, 6 for the equation, y equals 2x plus 4, that means I'm just replacing x and y with my x and y from the coordinate. So I have 6 equals 2 times 1 plus 4. And of course, this comes out to 6 equals 6. So that means that yes, that is a true solution. Let's do an example where we graph. All right, systems of equations. Like I said, a system is two or more equations, and in order to solve a system, I have to find the coordinate that will make both equations true. So the example I just said, where I had 1, 6 for y equals 2x plus 2x plus 4. If I plug that in, that's going to give me a true solution. So that's kind of what we're doing here. So what your graph will look like is if you have one solution, it means I have two lines that cross at a certain point. And the point that they cross at is the solution. If I had no solutions, that means I have two lines that run parallel to each other. So your graph might look something like this. These lines will never cross. They will go on and on forever on the graph and never cross. And then there are going to be some lines that are going to end up being the same lines. And that means that there are infinite solutions. So let's do an example. All right, go ahead and write example 1, and then y equals 2x plus 3, and then negative 2 plus y equals 3x. Make sure that when you are graphing systems of equations, that both of your equations are in proper slope-intercept form. And right now, this second equation is not in proper slope-intercept form because y is not isolated. So in order to do that, I just need to add 2 to both sides to get y on its own. My 2's will cancel out. I'm left with y equals 3x plus 2. Now I can go ahead and start graphing these. And it doesn't matter which line you start with. It really doesn't. So let's just do the first one. Let's graph y equals 2x plus 3. And of course I know when I graph, I start with my y-intercept, which is 3. I'm going to put a dot on the graph where y is 3. And then I see that I have a slope of 2, which is the same as 2 over 1 for rise over run, which means I'm going to rise 2 spots and go to the right 1 spot every time. Now, on these, you want to make sure that you graph the entire line for your entire graph so you can figure out exactly where the two lines will cross, if they cross. So if I want to extend on this side, I go down 2, over 1, down 2, over 1, down 2, over 1, down 2, over 1. I'm going to go ahead and draw my line so I can see where the line will cross. So I went ahead and graphed that one, so I'm going to go ahead and cross it off. Now I'm left with y equals 3x plus 2. So I know that I start at 2 because that's the y-intercept. I have a slope of 3, which is the same as 3 over 1. So that means I'm going to go up 3 and over 1. Up 3 and over 1. Now I'm going to do the same thing on this side. If I want to extend on this side of the graph, I go down 3 and over 1. Down 3 and over 1. And if I go ahead and draw my line, it's a very steep line, I see that my graph, my two lines cross at 1, 5. And since my lines cross, this system of equation has one solution. That means I could plug in both of these numbers for my x's and y's in both solutions, and the equations would be true. Let's do another one. All right, I have y equals 3x plus 4 and y equals 3x plus 2. These are both in proper slope-intercept form, so I don't need to do anything. All I have to do is graph them. So let's start with our first equation. Y equals 3x plus 4. I know that 4 is my y-intercept, so that's where I'm going to start. I have a slope of 3, which is the same as 3 over 1. So I'm going to go ahead and rise 3 and go right 1. And then I'm running out of graph, so I'm going to extend on this side, where I go down 3 and over 1. And down 3 and over 1. And down 3 and over 1. I'll go ahead and draw my line. Now I'm going to graph my second one. My starting point is 2. And since I have a slope of 3, I'm going to go up 3 and over 1. Up 3 and over 1. I'm running out of graphs, so I'm going to go down this way. Down 3 and over 1. Down 3 and left 1. Down 3 and left 1. If I draw my line here, this is a super, super steep line, both of them. But these lines will never cross. See how they are completely parallel to each other? And of course, if our lines don't cross, that means that I have no solution. And that means that there is no number that I could plug in for these equations to make both of them true. All right, guys, this is a little bit of a complex skill, so I think it's best that we just move right into practice. So let's get started.